Hey, what's up guys? Today we'll be going over the forces between like polar molecules and non-polar molecules and all that. So we have hydrogen chloride and hydrogen chloride. These both are polar. Chlorine is more electronegative. It would require more electrons. Hydrogen receives octave with 2 electrons. So they share. This has technically like 6, and then this is a 2. So it technically has a partial negative charge. Negative charge. Negative binds to positive. You got dipole and dipole. As a result of the electrons kind of being passed here, because it's polar, it's considered because they're two polar molecules kind of binding together, partial negative positive charge. It's called dipole. You have dipole induced when a polar kind of binds to non-polar. This is a non-polar and this is a polar, that's water. So with the partial charge of water, it's changing the charges here. The electrons here on oxygen, which is concentrated more, is repelling the electrons on this oxygen, pushing it here. So that becomes partially negative. This one positive. Positive binds to the negative site. You have dipole induced. And we have London dispersion. London dispersion is between any non-polar molecules. So chlorine and chlorine, they bind together. It's non-polar. These are non-polar. So when they come together, they kind of induce a charge on each other. So when these come here, like this could possibly repel electrons here. This becomes positive, this becomes negative, and this is already negative. So the negative binds to positive, and so we have what's called London dispersion. This temporary, it happens like for a temporary set of time, and then it breaks off. It does not stick. Here, it's temporary for the non-polar, but permanent for the polar, and here it's permanent for both. These are kind of fixed partial charges for the polar molecules.